Hi YouTube, it's me again and welcome back to my channel. For today's video, we will answer some basic questions on introduction to topology and metric spaces. So let's start now. Okay, so let's start now. We rewrite true if the statement is true and we write false if the statement is false. So let f from x to y be a function and we refer x as the domain of inputs and y as the range of containing the outputs of the defined function. So di ba sa function natin, if you have f from x to y, if this is the domain, this one is codomain, it only contains the range. So hindi yung y mismo kasi hindi naman natin sinasabi that the function is surjective. So therefore, it's false. Number 2, if this is an arbitrary collection of sets in a metric space, then the union of the collection is closed. Now, close kasi siya. So, pag sinabi kasi natin ditong sets, so ibig sabihin arbitrary sets. So, how about those are open? So, hindi siya magiging close. So, therefore, it should have to have close para mag-close din yung union niya. Similar with, so this becomes false. And similar with number 3, close kasi siya. So, dapat i-close mo din yan. Kasi hindi naman pwedeng arbitrary sets lang. Okay, number 4. A subset X in a metric space S is open if it contains an open ball. And we know this for a fact that if S contains an X, so yung X mo magiging open. Pag ito yung X mo, and then you have an open ball, let's say you have X there. So, meron kang, let's say, a radius of delta. So, parang may open ball ka sa loob. We know that for a fact. So therefore, this is true. Number 5, the function f from the metric space, this to this is continuous if and only if the preimage of every open set U in T is open. And this is true. This is definition of continuity. So that one holds. Okay. Okay, so for test 2, which of the following is false about the claim of for a countable set? So kung titingnan mo, number 1, a set A is said to be countable if there exists a one-to-one correspondence between the set of all natural numbers to a set A. In fact, this is a definition for a countable set. So mayroon ka talagang one-to-one correspondence from your given countable set to the set of natural numbers. So this is actually true. And A is countable if and only if A is a subset of N. This is in fact true. And then if A is countable, a set A is countable if and only if there exists a bijection between A to any subset of N, and this is actually a restatement of letter A. So when we say it's a one-to-one correspondence, therefore it's a bijective function. So letter D, a set A is countable if and only if it can be made finitely into another set. We can do that. We cannot do that. So therefore, this is letter D. Okay, for number 2, which of the following can be regarded as a counterexample of being a metric space? So, titingnan natin sila. So, paano nga ulit yun? Remember that for the rule for being a metric space, row of xy is 0. So, this is if and only if x equals y. And then for number 2, row of xy, dapat this is the same as row of yx. And then number 3, row of xy, this should be less than or equal to row of xz plus row of zy. So, ibig sabihin parang may sisingit doon. So, this is triangle inequality, di ba? So, we will check. Kung napapansin mo, if you equate f equals g, so yung row niya, magma-minus yan, magiging 0, and that's actually true. And then, pwede mo siyang iswap ang places nila. So, magiging mag-swap siya dyan. Kasi, square naman siya, so it's still the same. And then, this is a function, so pwede kang sisingit doon, and that's evidently greater than that. So, therefore, this is a metric space. For letter B naman, this one, pag ganito, di ba, this is defined as the square of x minus y. Okay. Well, double check. Kasi kung titingnan mo, let us say, ano ba? At 3, 1. So, kunyari, in R kasi, so that's row of 3, 1. So that's equal to 3 minus 1 squared, and that's equal to 4. So kunyari, isingit tayo ng 2. So row of 3, 2, and then plus row of 2, 1. So, di ba this is 3, 2. So, ibig sabihin that's 3 minus 2 squared plus yung 2, 1, 2 minus 1 squared. Di ba this is equal to 2 lang and it's not greater than or equal to 4. So, therefore, this disqualifies to be being a metric space. So, number 3 kasi vector space eh. So, ibig sabihin, if your vector alpha is equal to the vector beta, then automatically the norm pala, sorry, of this is 0. And then, pwede mo siyang i-swap kasi naka-norm naman sila. And then, the triangle inequality, pagsasali ka. In fact, isa to sa isang sikat na example for being a metric space. So therefore, the answer is P. Okay, for number 3, which of the following is true for accumulation point? A point P is accumulation point of A, which is a subset of X if and only if for every open set G, this one holds. In fact, this is a definition of accumulation point. So, mangyayari dito, this is true. Ito naman, this is the same restatement of letter A. So, this is true. Kasi sabi dito, it is an accumulation point of a subset A of X if and only if there exists an open set. So, itong open set na G sa A, pareho lang dyan, na nag-contain ng point ni A not equal to P. It's the same as having the intersection is not empty. So, therefore, it's true. For letter C, a point P in X is an accumulation point if for every element in the subset X, P is different from it and that P does not belong to any of those sets. Hindi naman necessary na wala siya sa sets. Pwede namang andun siya, pwede hindi wala. So therefore, this is false. So the only true here is this. Number 4, which of the following is true for the context of function? I was all asked by my mom to assist the visitors in our party such that there should always have one bowl of salad in every visitor in the house. So you have a visitor here and you have a salad. So parang sinabi yan, there is a correspondence for every visitor to have a salad. So therefore, it's a function. Letter B, I was informed by my brother that he bought a can of beer and every time we have a party, we can drink until the morning. There is no message on this, like, napaka-ambiguous niya. So, ibig sabihin, hindi siya talaga ma-declare as a function. Number 3, I went to a bar with my friends when we bump into some old acquaintances and so we meet a lot of newfound friends in every table we bump into. It's still ambiguous kasi kunyari ikaw to, tapos ito yung mga bar. So, ibig sabihin, okay, so number 5, which of the following is not a topology on X having 3 distinct elements? So, kunyari, this is your A, this is your B, this is your C. So, ibig sabihin, yung tao mo dito contains the MT, the X, your AB, and the C. Hindi. Wala na tong C. So, yan lang. So, kung tutuusin mo, that is a topology kasi alam naman natin the intersection and the andyan, empty. The union andyan, the intersection with this one, and then the union is the X mismo. And for this letter B, so kunyari ito yung A, B, at C. So your tau here is the empty, the X, the A, and the BC. So if you take the union sa dito, magiging X. If you take the intersection, magiging empty. So that's correct. For letter C, kunyari, this is A, B, and C. So yung tao mo is the empty, the X, the A, C, the B, C, and the C mismo. So if you take the union of these three, A, B, C. If you take the union of these two, A, B, C pa rin. If you take the intersection of this, C, andito. Yan. So, therefore, it's a topology. Ito naman, A, B, C. So, yung tao mo is empty, the X. Ano pa? We have AC. We have BC. Pero if you take the intersection, dapat C, wala siya dyan. So, therefore, this is not topology. So, the answer is letter D because we're looking for not a topology. Okay, so let's go for test 3. So, for test 3, When can we say that a mapping is well-defined? So parang pinasasabi tayong definition, no? A mapping F from X to Y is well-defined. Yan. Paano naging well-defined? If for every X in X, there exists a Y in Y such that F of X equals Y, and if X sub 1 is equal to X sub 2, then F of X sub 1 is equal to F of X sub 2 for all X1 and X2 in X. For number 2 naman, a function F is surjective. Yan. So, di ba pag surjective, mag-i-equal yung range at yung codomain. So, this becomes surjective if for every Y in Y, so ibig sabihin lahat ng elements sa Y, there exists X in X such that F of X equals Y. So, lahat ng elements ni Y na mamap kay X. So, that makes it surjective. So, number 3 is F is injective if F of X is equal to F of Y implies X equals Y. Di ba, ito naman yun talaga, nagpo-prove tayo dati, like, you're given with a locus, and then you're asked up to verify if that function is actually a one-to-one or injective. So, ibig sabihin, di ba, i-equate mo siya sa F of X equals F of Y, and then your conclusion should have X equals Y. So, yun naman talaga yung, pagpo-prove. And then, number 4, bijective. So magiging bijective siya if it's both surjective and injective. So we know that for a fact that a bijective function is an onto function and a one-to-one function. That's it. How about for letter B? So yung letter B, let F from A to B, and then A sub 0 is a subset of A and B sub 0 is a subset of B. Show that A sub 0 is a subset of F inverse of F of A sub 0 and that equality holds if F is injective. So, paano yan? Prove natin. Ang drop lang to ha. So, let X in A sub 0. So, anong magiging mangyari yan? So, then, yung F of X mo is an element of F of A sub 0. Tama? Okay. By definition of a function. And then, anong mangyayari? Ita-drop ko na lang to, so mag-a-arrow lang ako. F inverse of F of X. So that's the same as element of F inverse of F of A sub 0. What is F inverse of F of X? Di ba that's X? So ibig sabihin, it's an element of inverse of F of A sub 0. So dahil yung X mo na galing kay A sub 0, naging element niya dito. So the conclusion is A sub 0 is a subset of F inverse of F of A sub 0. Okay. Now, the equality holds if F is injective. So ipapakita mo na yung A sub 0 also contains F inverse of F of A sub 0. And this holds only if F is injective. So paano yan? Sige nga. Let X be element of F inverse of F of A sub 0. Diba? Dito tayo magkukuha. Tapos yung conclusion natin, dapat makikita natin yung X dyan. Okay. Paano? So implication nito, this is F of X, element ni F of F inverse of F of A sub 0. Tama? And so this implies F of X is an element of, so mawawala to, this is F of A sub 0. Tama, no? So, ibig sabihin yan, F of X is equal to F of Y. Sige, gamit tayo ng ibang variable, X sub 0 na lang. For some X sub 0 in A sub 0. Tama? Kasi, di ba, dahil ito, element niya, so ibig sabihin, ito can be equal to some like this na nandun dyan. Pero, since F is injective, ibig sabihin, X is equal to X sub 0. Since X sub 0 is andun kay A sub 0, it follows that x is an element of a sub 0. So this implies yung f inverse of f of a sub 0, kasi di ba element niya yung x, pero naging element ni a sub 0. So it's a subset of a sub 0. So therefore, equal sila. Okay. So if you have any questions or clarification, please let me know. So how about for number 2? Okay, for number 2, when can we say that x together with a function, this one is a metric space? How do we define that? A set x together with the function d x cross x to 0 infinity is a metric space if the following are satisfied, completely satisfied. Number 1, for every x1, y1, and x2, y2 in x cross x with d of x sub 1, y1, x sub 2, y2 is 0 if and only if eto siya, sulat ko na lang dyan. So, eto siya, they are equal. Okay, number 2, yung d of x1, y1 mo, x2, y2 mo is the same as d of x2, y2, x1, y1. And number 3, ano nga yun? D of x1, y1, and x2, y2. This is less than or equal to d of x1, y1, x3, y3, plus d of x3, y3, x2, y2. Okay, so that's the definition lang. Okay, for letter B, show that the function defined by this is a metric space. So madali lang to. Paano ba? If x1, y1 is equal to x2, y2, then x1 is equal to x2, y1 is equal to y2. Thus, ano mangyayari? D of x1, y1, d of x2, y2, this is the same as the max of y1 minus y2 and x1 minus x2. Yan. So y1 minus y2 because they are equal, so that's equal to 0. Ito naman 0, so the max is 0. Okay, so condition 1 for a metric space is satisfied. How about condition 2? So let's try. Actually, we can swap. Dito ko na lang titingnan ha, guys. We can swap this. So kunyari, eto siya dyan, and then this one is dyan. So, di ba magsaswap lang yung location nila, y2, y1, eto, x2, y1. And that's still the same. Kasi, ano siya naka-absolute value naman. So, pwede mo siyang iswap. Although it's negative, it's still the same having result. And for 3, pwede mo siyang i-add, and that's already a metric space. So, that's it. It's pretty obvious. Number 3, suppose SP is a metric space, S row. So, given a point x sub 0 in S, when can we say that there is an open ball in S with a center x sub 0? So, letter I. So, we say there is an open ball in S with center at, ano yung center niya? X sub 1, x sub 0, if B of x sub 0 delta is equal to x in S such that x row of x sub 0 is less than delta for any delta greater than 0. Okay. For number 2 naman, or double I, given x sub 1, when can we say there is a closed ball? So, mangyayari, we say na may closed ball siya with center at x sub 1 if B of x sub 1 delta, yan, this contains the set of x in S such that row of x sub 0, 1 is less than or equal to delta. So, ito lang yung pinagkaiba ng open at close. Yung open kasi, strict siya. Dito naman is less than or equal. Okay, for number 3, when can we say that P is open and then P is closed? This is a subset of a metric space. A subset P, subset ni S, is open if for every P in P, there exists a radius, let's say R, greater than 0. Your R is dependent on P, such that yung open ball, PR, is a subset of P. So, ibig sabihin, it's the other way of saying a subset P is open if it contains an open ball. So, P is closed if and only if S minus P or the complement of P is open. That's it. So, if you have any questions or clarification, please let me know. Okay, number 4. So, suppose S, this one is a metric space. Show that if the union of all UI, I from 1 to n are open sets, are collections of open set, is a collection of open sets, then the intersection of UI is open. So, paano natin yan isosolve? Di ba, para magiging open set, so ibig sabihin, it contains an open ball. So, fix muna tayo. Fix P, element of the intersection of UI, I from 1 to n. Then, ano to? For all I from 1 to up to n, yung P mo is in UI. Kasi alam natin kasi na, di ba, element siya ng intersection. So, ibig sabihin, element siya sa bawat elements na yon. Okay. Anong mangyayari yan? Since yung UI mo kasi is open for all I, there exists a delta I such that yung B of P delta I is in the UI. Kasi alam natin this is open. So, ibig sabihin, ang pagiging open nito, nagko-contain ng open ball, which is nakakreate tayo ng open ball there sa P. Okay. So, anong gagawin natin? Let delta be the minimum of all di such that your I is from 1 up to n, di ba? N tayo. Okay, good. N. So, kailangan natin kunin yung minimum kasi kukuha lang naman tayo ng pinakamaliit doon eh. So, anong implication? Then, your delta is greater than 0 kasi siya yung minimum pero lahat ng elements ng lahat ng delta I mo should always greater than 0 para makakreate ka ng open ball. Okay. Then, gagawa tayo ng open ball. P of delta. Kasi si delta is a minimum of all the delta i's. Ibig sabihin, this is a subset of B of P delta I for each I from 1 to n. Diba? Dahil ito is a subset of this, so B of P delta is in the intersection of UI, I from 1 to n. So, dahil nag-contain na siya ng open ball na yan, so, therefore, mag-conclude na tayo that this one is open. Yun lang. That's it. So, that answers this one. Okay, number 4. Given a non-empty set gamma, when can we say that a tau is a topology on gamma? Okay, so this is a definition of topology. So, paano natin? Given a non-empty set gamma, sorry. A tau is a topology on gamma if, of course, tau is indeed a collection of subsets of gamma. Of course, this should be a collection first requirement, such that, number 1, the empty and the gamma is in tau. Number 2, if the script U is a subset of tau, then the intersection of all U, your U is an element of the script U, is in tau. So it's actually, I'm sorry, it should be union. It should be a countable union. And number 3, if U1 until UK are in tau, then the finite intersection of all UI, I from 1 to n, is in tau. So una, yung empty at yung gamma andun kay tau. Pangalawa, yung countable union, and then the finite intersection. Okay, for letter B, if tau sub alpha is a family of topologies on X, show that the intersection of tau sub alpha is a topology on X and is the union topology on X. Sige, sige. How do we prove that? Okay. So if this one is equal to tau sub alpha, so anong ibig sabihin nito? 'Di ba si tau sub alpha is topology na? Kasi 'di ba this one kasi alam natin that tau sub alpha is a collection of topologies. So ibig sabihin nun, X and the empty are elements of tau. Okay. Kasi it contains all the alpha. I mean, it contains all the empty and the X in each alpha. Okay, now, suppose this one is an index family of non-empty open sets in tau. Okay, so ano mangyayari nun? So, ibig sabihin pala, U of B is an element of tau sub alpha. And this is for each alpha. Tama? So, your U is equal to the union of U sub B in beta. Ibig sabihin, kasi for all siya, this U here, which is the union sa lahat ng U sub beta, is an element of tau. So, ibig sabihin, U is open. And so, it's that way. So, lastly, suppose U1 up until UN is a collection of non-empty open sets in tau. Okay. So, since U sub k is open in tau sub alpha, and this is for all tau sub alpha, di ba? Okay. So, ibig sabihin, your U, kunyari, lagyan natin ng label, let's say U prime is equal to the intersection of UK, K from 1 to N. So, di ba yung UK is open in tau sub alpha and that's for all alpha. So, ibig sabihin yung intersection niya is open. So, this is an element of tau sub alpha. So, nag-imply yan na U sub K is an element of tau. Therefore, topology talaga siya. That's it. So guys, if you have any questions or clarification, please let me know. Okay, that's all for today, and thank you so much for watching. If you have any questions or clarification, please let me know so that we can talk on that. And if you are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon. Thank you. Have a great day.